Kia ora koutou, welcome to this Science 1.1 mechanics video on kinetic energy. Kinetic energy is the energy of movement. That was just a fast car overtaking a slow car, in case you didn't pick that one up. So we'll get straight into the formula of kinetic energy. So think about these two cars. Which one would have had the greatest energy, do you think? And how do you base that opinion? So this car had a greater velocity than the other car. So it makes sense that objects with a greater velocity would have a greater kinetic energy. What if we had a car driving at the same speed as a truck? So the car had a far lesser mass than the truck did. Which one would have the greater energy in that case? Well, the truck would have the greater kinetic energy than the car, even though they were both traveling at the same speed. So there's two things that influence the kinetic energy of an object. First of all, we need to know the mass of the object. Something with a greater mass that is moving will have a greater kinetic energy than something that has a lesser mass. And the velocity is the other variable that affects the kinetic energy of an object. So the formula for kinetic energy is EK, where E stands for energy, and K is kinetic. So EK, kinetic energy, it's similar to the EP that we saw in the last video, where P stands for potential. So that was potential energy, this time it's kinetic energy. The formula for it is EK equals half. So this is a trickier formula than what we've come across before, but it's half of the mass times the velocity squared. So we'll do an example of how to work this out. So let's say this car here, we'll say that it has a mass of 1,000 kilograms. So this car is 1,000 kilograms, and we'll say that the velocity of the car is 10 meters per second. So with these two values, we will be able to work out the energy that this car has. So the mass of the car is 1,000 kilograms. So we just need to go half of 1,000, and then we times that by the velocity squared. So 10 squared. So half of 1,000 is 500. 500 times 10 squared. So to square a number, you just need to times it by itself. So 10 times 10, that equals 100. So these are relatively easy values to use, but most of the time you'll need to use your calculator. So 500 times 100, we just add two zeros to this 500, and we end up with 50,000. So 50,000. And remember the units for energy, it doesn't matter what type of energy we're talking about, the units for energy are always going to be joules, which is a capital J. So using this formula is different to what we're used to. It's not just one variable times another. We have to half one and then square the other, which makes this quite tricky if we're wanting to rearrange it. So what say we knew the velocity, or rather, what say we knew the mass and the energy of an object, and we wanted to work out the velocity. We would need to rearrange this equation so that V was on the other side. So V equals EKM something. We need to work out how that formula would work. So we'll work out how to do that. We'll work through this together. So we've got kinetic energy equals half mv squared. To put everything except the velocity on the other side of the equation, we just need to do the opposite of whatever we have here. So we're going to start off with this half sign. We can get rid of that and put that on the other side of the equation by doing the inverse to it. So instead of halving this side of the equation, we're going to times it by 2. So we go that mv squared, that whole thing times 2. And I'll do the side on blue, and then we times the other side by 2. And so by doing that, we can cross out the times 2 and the half on this side, and we just end up with 2ek equals mv squared. And so now we want to get rid of the mass on that side of the equation, so we can divide both sides by m. So divided by m, and because we're dividing, we've got m divided by m, we can cross both of those out, and we end up with 2ek divided by m equals velocity squared. And so the final part to get rid of that squared sign is that we need to take the square root of that velocity squared, and then we've got that sorted. So we'll cross out the squared sign and the square root sign on that side, and we'll put it the other way around to make it easier to read. So velocity equals the square root of 2ek, square root of 2 times the kinetic energy divided by the mass. All right, so we will go through an example of how to work out the velocity of an object when we know the mass and the energy. So we'll say that the fast car has a kinetic energy of, let's say, 70,000 joules. And let's say its mass is a little bit lighter than this car. We're going to say that it is 900 kilograms. So this car has 70,000 joules of kinetic energy, and its mass is 900 kilograms. What we want to do is work out what the velocity of this car is. So we need to work out the velocity. So we use the formula that we've just derived. So velocity equals the square root of 2 times ek divided by 900, or divided by mass. So we'll put those values in. So we're going to go 2 times 70,000 divided by the mass, which is 900. And that's going to equal, so we'll just do little bits at a time in your calculator. We'll go 2 times 70,000, and then that divided by 900, and then we'll take the square root of that value. So I'm going to pause the video and work that out myself. I'll give you a chance to do it too. So that equals, hopefully you got the same value, 12.47, or let's say just 12 meters per second. The number of significant figures that you use doesn't matter so much for this. Well, you won't be marked down if you don't use the correct significant figures. So 12 meters per second, that was faster. How fast did we say the other car was going? So we said the other car was going at 10, so this is going at 12 meters per second, which makes sense because it overtook that car. So looks like we've got a reasonable value there. Thanks very much for watching this video. In the next video, we'll talk a bit more about the conservation of energy. Like and subscribe for more Science 1.1 videos. See you next time.